and welcome back to everybody else. Once again, thank you for joining us for GED Day today. My name is Amy Ferrari. I am the Director of the Adult Training and Development Network, otherwise known as ATDN, and I will be your moderator for today. All sessions are recorded, all materials, presentations, anything that's utilized, we make available to those who have attended after GED Day via email. Please just give us a little bit of time to get that turned around, hopefully the beginning of next week, obviously being that today is Friday. Please feel free to post any questions or comments that you might have in the chat during the presentations, or of course, unmute yourself to participate. So I'm thrilled to introduce today's third session. Will this be on the GED test? Our presenter taught GED prep for over 20 years in a variety of settings. She now develops curriculum, coaches teachers, provides program-based support, and delivers professional development in adult numeracy as our Connecticut math consultant through ATDN, and also in partnership with Turk. We'd like to welcome Connie Rivera. And Connie, thank you so much in presenting for us today.
Thank you. And I recognize some faces of people I know and some that I haven't seen in a long time. So nice to see you. I am interested in talking about this student work. And I know that as you join, you might not see things people posted earlier. Just to summarize some things I see in the chat, Lisa pointed out that the student is using the keyword of difference and deciding that that must be the operation that they need to do, which would be subtraction. But correctly, they got the answer wrong, but it was based on their misunderstanding of language. And I wonder, is that just about language? Because I feel like the student did a lot with language in their own writing. Denise said they're confused about what to solve for. And reading too fast is something that can lead us down the wrong path, Jane's pointing out. So this is actually work from an adult education classroom. This is real student work. And I'm friends and colleagues with this teacher. And he was, this is from the beginning of his career. And he was teaching students the keywords. And then they came across this problem, and he realized that she did everything that she was supposed to do. She even checked her work. She wrote out everything. She explained how she knew how to solve it. And yet it is a misunderstanding of the result. I saw somebody earlier put the amount. Nicholas is saying that ESL students and language can be a concern for the GED test. And I would say that this would be whether the student was American born and speaking only English, it still is a problem because of so many factors that go into it. So we can learn a lot from student work. It's a good example of student thinking where it doesn't involve the sense-making piece, but she did all the things. She followed the steps, even for a word problem. So if you were here last year, you saw this problem in a session by Erin Liu, who created the Will This Be on the Test blog series and a corresponding packet about test talks. And that's what we're going to be working with today. This is a new session with the same topic, but we're going to have different questions. So even if you were here last year, this is the only parts that's the same. I just couldn't find a good replacement that of wrong answers that was as clear as this one. So there's our opening slide with all the logos and our objectives. Basically, I want to talk a lot about visualizing and pictures that we can create to explain our thinking and the concepts, because I think that's what's missing from at least the way that I was taught math growing up, but also from a lot of the materials that we have in adult education. It's a case of we tend to take the lowest functioning students and give them just the here's how to do it, memorize it, when that hasn't served us well. And research tells us that, but we're sort of stuck on that because we're not sure what else to do and it feels efficient. And we're going to spend most of our time in this session on the test talk routine. We're going to be experiencing it and peeking behind the scenes at teacher moves. So you're going to see the whole test talk routine. I know that this feels like it should be number one. I'm jumping in and just talking about a few pieces of it that are all connected to the Paulina question. And then we'll go back through and experience a test talk together from the beginning where we alternate looking at the teacher side and the student side. So um, if this was a test talk and you assigned the question, this is the Paulina's age problem. That's number three. Number four, you'd give students think time. And then number five would be to facilitate strategy sharing. Students might not have many strategies when you first begin doing test talks, and they're less likely to generate some visual conceptual ideas when you first begin. But if you make space for them to share before you share, then and they see some other ideas and hear from other students, more creative and visual strategies will appear. So to solve the problem, one student might have drawn a picture showing Paulina as the taller adult and her son labeled as 8 years old, like a height. And then between them, there's a 35-year age difference. Another student might visualize a number line, and that shows the 35-year age difference with the son's age to the left and Paulina's age still in question on the right. Another strategy that students might share is a bar model. And other names for bar models in our college and career readiness standards, they're called tape diagrams. They're often referred to as Singapore strips, and that's just because of where this way of representing originated. So you can help everyone make comparisons of, okay, this student shared a bar model, this student shared this drawing, what's similar, what's different? Someone else might share an analogy to talk about how they thought about the problem. So they might have said, I'm 28 years old, my daughter is 5. The difference between our ages is 23. So how would I get from her age to mine? If, if they use an analogy approach like this, we can find that kind of reasoning in Math Practice 1, which tells us that mathematically proficient students consider analogous problems and try simpler forms of the original problem in order to gain insight into its solution. So now we're engaging with the math. Everybody's hearing these strategies from everybody. Most students don't consider making sense of a problem. It's really common to apply tricks or look for keywords and to try to remember procedures. We sometimes look at a problem and even as teachers we say this like it's one of these kinds of problems, like it's a systems of equations problem, it's a whatever the thing is, and we label it, and then students might think, okay, well I need to do this thing to it, but I don't remember how to do that thing, and now they're stuck. Sometimes we look at a word problem, we just start doing something to the numbers. Maybe it's using the keyword, maybe it's not. Maybe it's this is what we've been doing in class, this must be what I do to the numbers, and they're not seeing the relationships and making connections. If students spent some time making sense of what they know, in this problem that includes noting that Paulina must be older than her son, because that's how it works, and it must be by 35 years. So this is setting up a routine for making sense of unfamiliar problems so that students can tackle problems that are out of reach if they were just using keywords and tricks. So, like I said, especially at the beginning, students are less likely to share these visual and conceptual strategies. That will probably happen in this group too. But you always can have prepared ideas behind to share. And then as you do the routine more often, they will start to see things a little differently, hopefully seeing math as more flexible. So they might not have those skills yet, but they're going to develop it a little bit at a time. And because it's routine, the more often they're in class, they'll be developing more and see the value in drawing pictures and thinking creatively rather than thinking they have to memorize everything. So, um, when I click these, you're going to be like, oh, yeah, that makes sense. But I'm going to tell you there's three kinds of problems on the GED test. Only three. Um, but here's the categories I'm thinking of so that we can put that in the context of why we're doing this routine. There's problems that they will know how to do. There are problems that are completely unfamiliar and inaccessible to them. And then there's this sweet spot here where we can really support them in tackling more problems. There are problems on the test that they know how they don't yet know how to do, but they can find a way into. It might not be how the test creators expected it to be solved, but with reasoning and multiple choices and the mindset that they can tackle problems they haven't seen before by making sense of them, they're going to expand their ability and their belief in their ability to engage with problems by making sense of them and using what they do already know. It is empowering them to become sense makers because they know that they can rely on their reasoning rather than like just freak out during the test, which I know could happen to any of us. So it's not about whether you know it or you don't, and you memorized them or forgot how to do that during the test. Memory is less reliable in general, especially in a test situation, but trying to cram and then recall under pressure. So this gives them another way to look at it. One more GED thing before we get into the routine. And I have a link to what I'm going to show you if you care to look at it right now. And it is the performance level descriptors. Oh, well, I copied the in-chat part too. The performance level descriptors describe what a student at each of the three levels below passing, passing, and college ready can do. Click. This is pages 4, 5, and 6, and 7. And there are so many things on this list. I notice you can't even read that. It's way too small. There's too much. I had to overlap them. That's because there's so many things on the list. There's going to be something that is completely inaccessible, but there's going to be many problems that students can find a way into and select a reasonable guess from the multiple options that are given to them. And then this routine will help them feel like they have permission to approach problems flexibly and creatively and give them themselves time to think instead of the anxiety when the answer doesn't come immediately. We're going to be here on this one page right here in this little section that I'm going to make bigger. We're going to be looking at a one variable linear equation for our test talk. Test questions are often written in that they should be solved in a specific way, but the idea here is that sometimes students can find their way in even if they haven't studied or mastered that particular standard. So our challenge is to put ourselves in the position of we don't know a step, we don't know procedure for this. We just know what those symbols mean and we can try to make sense of it. So the test talk isn't meant to teach them how to solve linear equations in one variable, but instead it's a chance for them to try something that they haven't been taught. So I didn't know who was coming. I didn't know what level we would be at. Obviously, it will be different. So I just selected something, and we're going to put ourselves in the position of students that don't know the procedure. So now we'll take a look at the test talk from both sides. And both sides means that I'll show you where we are in the teacher moves and go back and forth and take you through the test talk as learners. And then I'll take you back to the components to talk about how we address them. Here's something I want to make sure that you hear, and I think we've got everybody now. So it's numbered. It does not mean that these are steps that are like prescribed, that you have to follow all these steps. There's going to be like 9 steps or whatever that are appearing. It's just meant to break it down and help you find your place on the slides when you get them. And you should allow yourselves the same flexibility of how to use the test talk as you're allowing to your students and the way that they can think through a response. So we're going to do what makes sense as students because they're making sense of the problem, but also as teachers. So you're not going to try to like look at every single step as you're doing this. It's just meant to explain the whole process. The first component of doing a test talk with your students is to select a question. In the packet, there's guidance about how to do this, but here's two important points for now. Choose questions that you have not explicitly taught your students how to do. The point of this routine is not to provide students with all the practice skills and have them learn with a test-like context. The point is to help them learn to think flexibly and creatively in a test setting, especially when they don't have the memorized procedure for answering that question. If they did, they would have that would have been on the other kind of test question where they saw it, they knew what to do, they're done. So it's important that we give them practice by placing them in situations where it's going to require thinking. We're expecting it to take a while. And another thing to consider when you're selecting a question is to select a question that's not too far out of reach either, that they have some kind of fundamental understanding that they can, and maybe not every single student, but they can find a path to the solution. Not they fully understand everything, not they understood it the way that the test creators intended to assess their understanding, but they can do something to make sense of it. When we do a problem today, and after you read several blogs, you'll start to get more of an idea of how a student can have enough understanding to find a path to the solution without having the skills that were originally assumed to be necessary that it was assessing, that the problem that was created was trying to assess those skills. So again, there's more guidance on choosing questions in the packet. So what we're doing here is creating the conditions for productive struggle. And I know that when the college and career readiness standards came out, you started hearing that phrase a lot. Your students will struggle because you've offered them a task that they don't already know how to do. But hopefully they'll struggle productively because you've chosen something that they have some kind of understanding about, something connected to it. So during the session today, I'm going to give you a problem that I already got together, and you might not feel like it's a struggle, but hopefully you'll struggle in a different way than your students will, because my challenge to you will be don't use the standard algorithm if you look at it and know, I know how to do that kind of problem. The second step is to set expectations. So let me model that. I'm going to show you a question. And before I do, I want to remind you that what you can, I want to remind you what you can expect. I'm going to give you a challenging question and I'm going to give you time to think about it and time to generate a strategy. And then we'll have time to share strategies and talk about it together. If you have the procedural knowledge to get the answer quickly, challenge yourself to find another strategy, one that doesn't rely on things you have memorized. If you find a strategy and an answer and there's still time left, challenge yourself to find a different approach, a different way to do the problem. And I expect you to struggle. If you don't struggle, I didn't choose a good task for you. If you feel stuck and you can't get started, you can send me a private message in the chat. So these are the expectations that I would communicate to students every time. And I have a summary list here. Once they get familiar with the routine, the introduction to it can be a lot more brief because they know how it's going to work. They know about how you chose the problem. So here's the summary. You're going to let students know that they will have time to think. That's really important. Part of the reason for math anxiety is we started timing everything. We thought that the smart people were the ones that got fast answers. I will tell you that Einstein did not have a reputation for being fast. So we're valuing the wrong things when it's about the mad minutes and things like that. So time to think is important. It takes that pressure off. We give ourselves enough pressure. I do understand that the test is timed, but this is about preparing for the test. This is not about tackling the problems they already know how to do. This is about opening up their minds to ways that they can tackle problems that they don't quite know how to do, but if they spent time making sense of it, they could get these ones correct also. Make sure that students know that it's probably going to look intimidating or unfamiliar, and let them know that you believe in them. You believe they have the skills to make sense of it, and then model that with your behavior by not rushing in to help them too quickly. Let them know that they're going to be asked to share their reasonings, so they know ahead of time that this is going to be conversational, and that they shouldn't just try to remember what to do. They should try to figure out something to do. So the goal here for you as teachers is to challenge yourself to think flexibly and creatively as if you don't have that memorized strategy. And because we have a limited time in our session, I'm going to give you about 5, 6 minutes to think of a way that you can represent this in something that is not here's the steps to follow. And I do understand that if you're new to that, it's very challenging. It's okay to do the steps just so that you got that out of the way and have something to compare to. But try to put yourself in the shoes of somebody who doesn't have those procedures already. Um, so during the time that we're having our think time, I'm Um, so I'm going to assign the question, and I will in a minute. During the time for think time, I'm going to ask you if you're going to chat only to me. So if you open up the chat, it says everyone automatically. If you click on that, you can find Connie Rivera, probably at the top of the list because I'm a co-host. And then chat just to me if you want to ask a question or you feel like you really need to say the answer because this is a math session because I'm not going to be interested in the answers, but in how you thought. So grab some paper if you don't already have it. Um, you will have the chance to describe your reasoning, but you also can hold something up to the camera so that we can see your reasoning as you talk about it. On the next slide, I'm going to give you a test question to work on. And it might be a test question, but it's not a test. I'm going to give you time. Here is our question. What is the value of x in the equation 6x minus 3 equals 21? There are 5 answer choices, 3, 4, 9, 18, or 24. I'm not interested in your answer. What I'm going to be interested in is your strategy. I'm going to set the timer and we're just going to be quiet for about 6 minutes and we're just going to keep thinking about different ways that we could solve this if we did not know the procedure for it. Do you have questions before we begin? All right, I'm setting the timer. Work on ways that we can solve this without using a procedure and think about how you could explain your strategy to somebody afterward. for me, that flew by. I was still answering people. Um, do, do any of you feel like you want some more time? Can you say yes, yes to more time or no to more time in the chat? I've gotten quite a few direct messages. Thank you. So it sounds like it would be most helpful to talk together about strategies so you can see some ideas for other ways that people were thinking creatively and flexibly with this. And I will point out that it's really hard. It's like I'm right-handed and I brush my teeth with my right hand, and you're suddenly asking me to use my left hand. My right hand was working just fine. Why do I need to try to use my left hand? I'm not that good at it. And when you are first starting to represent things that look basic to you because of where your math skills are at, then it's really hard to put your toothbrush in your left hand, so to speak. Um, so the idea here also is to share like how you thought about it. And that means the students are doing that. That's where we start. I'm going to click that up. I have a slide that says that next. And that's what we're going to do now. So I'm not going to like tell you the steps of how to solve 6x minus 3 equals 21. I'm not going to say what the answer is and ask how you got it. What I'm interested in is how did you think about this? And it may be that you're describing something, maybe you're putting something up to the screen to show us. And so that's what I'm interested in right now. If you have something you wanted to share with the whole group, don't forget to change it back to everyone. And also, please feel free to unmute. We might stumble since we're a large-ish group, but we'll eventually figure out who can talk first. So unmuting would be great. And I also can only see about 8 of you at a time, so feel free to just start talking. And the question is, how did you figure out? I'm going to go back so you can see the question while we do this. How did you figure this out?
Well, I assign a table of values for x. That's what I will do. 6 times 1, and then 6 times 2, until I get to the result of 21. That's how my students would think about that.
Okay, so you put a table. I'm still catching up to get on this slide so I can write. Hang on a second. Okay, you put together a table and you said that it's 6 is on one side, or did you say x?
Yeah, so I will say 6 multiplied by 1, take away 3. 6 multiplied by 2, take away 3, until I get to 21.
Like this?
Yes.
Okay. And that's a way to see a pattern. Is that coming up here? Yes, very messily, but that is. Thank you for sharing. What other ways did you see it? Annette said that she shares your method, Cesar, of how to set up a table so we can get to the result of 21. Let's see. Going back to a private answer that I'd love to have you share. Cheryl, would you mind talking about how you reread that problem?
I guess I was thinking about some of my students, and if I ask them to please tell me to read it to me, if they didn't know what the six and the X even meant, they might
Mhm.
say it's something. I know I have to get 21 as an answer. So when I look at the left side of the equation, I have to subtract 3 from something. And so I kind of stopped there because I wasn't sure how much more a student might, if they didn't know what a six and an X next to each other meant.
hmm hmm
So that's kind of as far as I got.
Yeah, and if our students aren't ready for the X because they don't know that notation, we could talk about notation so that they know what that says. Um, and I like how that conceptually explains what's happening. Thank you. Oh, Deb has something here. Try solving with each of the choices provided and see which one will work. Let me add that to the list. Oh, let me move that down. Did anybody draw something? My observation is that most teachers drawing something is not their first go-to. I'm probably not most teachers that end up specializing in math because I really struggled with math as a student. So I have always tried to draw something. I've gotten much more effective at it, learning some strategies for specific kinds of drawings that I did not know when I was making it up. But I was probably somebody who would have drawn the mom and the son and put heights as if they were put ages as if they were their heights. I would draw things like that. I fell in love with bar models the first time I met them, back when I used to call them Singapore strips, and uh, uh, those are how I still think through a lot of things that math teachers tend to do as a procedure that comes easily to them. So I guess I'm sharing that because we want to also put ourselves in our students' shoes and remember that procedures are often fragile for them. They're not reliable. They're not sure what it goes to. They've forgotten one of the steps and they're misapplying it. Ooh, drew algebra tiles. Mark, would you be able to hold that up to the camera for us to see?
Sure. And give it a whirl here.
Yeah.
I drew like rectangles for the X's and little squares for the single numbers. I don't know if I can get closer
Oh,
here or farther
keep holding
away.
that up. I need to do the spotlight for everyone here. Did that help?
And then even after I drew it, I kind of thought of a few different ways that I would go about it.
Yeah. So for those of us that haven't heard of algebra tiles, can you say more?
So algebra tiles are like visual, tangible representations that we can use. They're different sizes to represent whether you have a constant number or you have a variable. Oftentimes, X's will be represented with long rectangles. Single values will usually be two colored. There'll be like blue on one side to represent +1. It'll look like a small square. The other side might be red to represent negative. They're easy to grab and flip over so that you can say that this was a positive or this was a negative. Even when you get into larger terms, you can do a big square that looks like the two rectangle sizes for the x, and that becomes x squared when you use your algebra tiles. For something like this, it would have just been rectangles and little squares. They're nice because they're sortable. If I had 6 rectangles, I could try to separate all my little squares into 6 piles. And if that's too much, maybe even just completely separate them in half and just say, all right, I'm going to get rid of these 3 rectangles and then get rid of half of my singles. And you continue to get it smaller and smaller until it becomes a little bit easier of a visual.
And algebra tiles can be a visual when we draw them. They're also a manipulative. Like there's virtual ones, but you also can have like these specific tiles and you can move them around. I loosely drew what you had. It doesn't completely show it.
It looks perfect.
So thank you. Tell students to draw a picture all the time. I don't mean a tree and kids, but rather anything visual. Thank you, Jane. What other drawings do we have to look at? Okay. I did come prepared with a few things that we'll look at in a minute, but I'm going to go back to those test talk components on the list that we're looking at. I wanted to spend some time on the steps 4 and 5 from the teacher side because I don't want to skip over the importance of the think time and that it's more than just giving quiet time. It's a big important thing that students need plenty of time to think and to reason and to struggle and to try different things. You can judge how much time to give your students based on how things are going in class. If you're teaching in person, that's a little bit easier to judge. You can set the timer for a certain amount of time and say, this is just a chance for us to talk. We're going to pause in 5 minutes. We're going to talk, and then you're going to go back to it so that it's a chance for everybody to hear some ideas. Somebody had said to me, like, more time's great, but I don't know if I have more ideas if you give me more time. And that's the case for students too. So we get the juices flowing and then talk about some ideas like, well, when Mark said that, it gave me the idea to draw this. And okay, and then you go and think through something for yourself and then come back again. So a big issue here, especially when students are getting used to this idea and this idea that they can like figure out some things for themselves instead of needing someone to show them how to do it, is that they might struggle to even get started. And I'm sure that happened here too, that some of you are like, oh goodness, like pressure during a webinar. Honestly, that's how I feel when I'm asked to do math in a webinar. Even if I'm not the presenter, I still have math anxiety and I freeze about that. I need more practice and more comfort with the people that I'm working with before my brain will think when I'm told, here's your think time, rather than, oh my goodness, who's finishing before me? And things like that just pop into my head. So students are used to teachers that are taking over and telling them what to do, and they might just be waiting for that. So let's think about what you can do when students are stuck, because it's tempting to step in when we see a student struggling and give them a hint or just suggest a strategy. But think about how this undermines the confidence and persistence that we're trying to help them build. And remember that in the beginning we said, I believe in you. I do believe our students can figure out problems without me telling them how to do it. But they have to know that I believe in them by all these little clues that are happening throughout. So you can just suggest that they restate the question in their own words. And sometimes that's really helpful to getting us started. Suggest that they consider what kind of answer would be reasonable. Encourage them to draw pictures. Those of you I was able to answer in the chat, that is what I said to a lot of you as you were working and sharing your ideas. And encourage them to use the think time to make sense of the question or identify what is making them stuck. So I'm going to give you a few minutes now to think about maybe a particular student, maybe it's your class. Think about what ways you might help a student who is struggling get started without taking the work from them. So I'm just going to give you 3 quiet minutes, 3 think time minutes to think about what other things can you when students are stuck, what else can you do? Or maybe you're thinking about a certain student or just anything about this idea about how do we support students when students are stuck? I'm going to stop you there because full disclosure, I wasn't supposed to click those ideas before I asked you that question. So it wasn't very helpful. There are still more ideas in the packet, so I'm sure there's some things. And I did get a chat message, and it's several different ideas to help students feel calm, like purposeful breathing, and um, if they're feeling safe in class, they can close their eyes and picture it rather than just being staring at the paper. Um, so I thought those were good, like anti-anxiety ideas, because sometimes that's what's interfering. What other ideas did you have? And how about any reflections about how you've supported students in the past, or your comfort level with watching students struggle? So I do want to acknowledge that it's really hard to not rescue and explain. And if you catch yourself doing that, you can apologize to the student and say, I'm sorry, I took over the thinking for you. That's silly because I know that you're capable of reasoning through this and I'm working on not taking over. Another thought, when students are taking the test, you won't be there to offer any strategies at all, no matter what they are. If we do practice some of these strategies with them, it's just these are strategies and ways to put it back on them so that they learn to trust themselves. So students internalize them and they bring them to the test with them because they're not bringing us. I also think it translates to other problem solving. I think about watching, I seem to be everybody's tech support lately, and I think about the difference in the people that are asking me tech questions and their patience with it. And this feels similar in a way because some people will spend a lot of time trying to figure something out on their own, and then somebody will want to throw it across the room and just ask a question and just get that quick like fix of like, I need the answer to this one problem right now. But the people who spend more time with it are the ones that learn more about how to use the technology and get farther with it faster. I never know what I'm going to think of while I'm presenting, but I think I like that one. I'm going to use it again. All right, back to these test talk components. The next step is strategy sharing, and every student should have something to say. I know that we didn't do that right here, but it's not about whether they've gotten the correct answer. And if they don't even have an answer, there's still something they can say about where their thinking was. They can describe their thinking, share their drawings. They can talk about their struggles, such as places where they got stuck or things that didn't work or ahas that they had. There's always something to say, and I want my test talks to go on until somebody has contributed something. And if they don't feel comfortable talking, whatever the reason is, comfort in class or language, they can show us something. So everybody's participating by contributing something to what was going on for them during that strategizing time. What are your thoughts about why it's valuable for students to share their strategies? Or disagree with me, because I'm posing that it's valuable for students to share their strategies. It takes time. And they've got this test, so how they got there is important. Thank you, Nicholas. Confidence, Deb. Yes. Denise also with confidence. Yeah. Mhm. I think it's also confidence is built not just from sharing your ideas with others, but from getting your ideas from other students, not just the teacher. You feel like peers with your fellow students, even if you think some of them are clearly smarter than you in math or whatever things you're telling yourself. They still feel like peers rather than like the teacher, who, of course, the teacher knows everything. Spoiler alert, they don't. But um, here's another one in the chat that saying something aloud can help us figure stuff out. Yes, that I'm going to bring that back to the technology example. There's something called rubber duck debunking, and it's just stick a little rubber duck on your desk, and when you have a problem with your computer, you tell the duck all about it and ask, like, what am I going to do about this? This is the problem, and you describe the problem to the duck, and what do you know? You figure it out. Does it ever happen that you try to ask somebody a question and before you get through it, you've got the answer? So that all fits together too. Another reason for strategy sharing is that it's honoring student voices. It broadens what's valued in math class I genuinely left high school thinking that it was all about having the correct answers, and I didn't have them, so I must be terrible at math because I didn't remember the steps. But I was great at puzzles and logic things and all these other things that I didn't think were math. So valuing thinking broadens who can be good at math. Thinking and persistence, which my parents always called stubbornness, but I'm going to call persistence right now, gets us farther with things, even if we have struggles. So if math class is no longer the place where it's only one right answer, but it's a place where there's room for lots of voices, lots of perspectives and ideas, even if there's only one right answer to a test question, there's not one right way to approach it or one right way to share it in class. So giving time for students to share their strategies and learn from each other is as important as giving them time to struggle productively with a question. But even after all the students have shared, you might still have something that you want them to see, like another way. Like, for example, right now, we didn't talk about bar modeling yet. And I would like my students, which is you right now, to start developing the skill of bar modeling, which actually is got some overlap with the algebra tiles that Mark suggested. So after everybody's had a chance to contribute, you might want to share some additional strategies that are appropriate for your students that didn't come up in the discussion. And in the packet or in a blog, if you're looking at one of the blog entries, you'll find several strategies for each question, that ways that somebody could think about it. And those are ones you could present as your ideas. So I'm going to share two of the strategies from two, well, sort of. I'm going to share a couple of strategies. So first, you could make sense of the story in words. So this will look a little bit like what I think it was Cheryl posted earlier. So there's a number that if I multiply it by 6 and then subtract 3 from that answer, I'll get 21. What number gives me 21 if I subtract 3 from it? 24. And there's a number that if I multiply it by 6, I get 24. So it might seem really similar to the approach of using an inverse operation to isolate x or whatever procedure you were using, but it's more concrete for students whose algebraic thinking hasn't reached that level of abstraction yet. That level of abstraction is going to be needed later, but you've got to make sense of it first so you can get there. We've got to have concrete and representational before we get abstract, so they can make sense of and read these symbols as easily as they do with words. Also, there's picturing the problem. So what minus 3 is 21? Well, I'm going to picture eggs because that's close to 21. It's a thing that comes in sets, and I often like think in threes when I'm thinking in 12s. So I can say a row of 6 eggs 4 times is 24, and then use 3, and that's use like cook with them or something, and that's 21. So I tried this problem out on a couple people. This is my husband's answer. And we could also use a story table. And Cesar talked about using a story table. And I remember somebody else chimed in about us having a table. So story tables allow us to break down things into a series of action one at a time and to guess and check from it. So like, what could X be? What if it's 3? And he had started with 1, but then I multiply by 6 and I get 18. And then if I subtract 3 from it, did I get 21? Nope. All right, let me try something else. 4. All right, so now I go to the top of the table in the next spot and I say, okay, multiply it by 6. I get 24. Now I subtract it by 3, I got 21. Oh, that was it. Maybe it's going to take a lot longer, but that's how a story table works. And I think that was similar to the 6 times, let's try 1, 6 times. It's just that it's got the things in a different place. All right, this is not going to be a perfect representation. One of my colleagues and I, Erin, actually went back and forth on this, and it's messy, um, but it's like process thinking. So it could be thinking about, all right, so I've got 6x minus 3 on one side of the equation, and I've got 21 on the other side, and I know that they're equal, so I made them the same length. And then I've got to equal 21, 6x's, and I've got this like minus 3 part. And that's where it's messy because that's not quite it. But if I take the 3 and I say, well, whatever this length is the 6x's, let me resize that. That's the part that's messy also. If I take that 3 and I say, well, that could be here, then I can see that 6x's is equal to 24. So just like with other visuals, they help us understand the structure and move us toward more abstract thinking. So eventually that like stickiness of showing subtraction will become less of an issue. Here's a different way to represent that, still with a bar model. So 6x's, and I know that whatever is equal to it is 3 less. So there's my 3 less part and the 21. And Erin pointed out that the 21 might need to come first and that the 3, you might have thought about that second. So either of those orders. I left up mine example, but another thing to point out is that we know in the long run that x is equal to 4, but it's just kind of convenient and pretty looking that I knew that when I made the model and the 3 is smaller than the x, but it might not have been. This is abstract. And if you didn't already know the answer before you were drawing it, you wouldn't know to make that smaller. And it doesn't need to be. It's about the thinking. I have another way. Let me pause and see if you have questions about the bar models while I'm here. We're going to look at number line next. What are you wondering so far about any of these strategies I've shared? I also know that if you're looking at bar models for the first time, that it's like, oh, like I hadn't thought about that. So I can click back through those again if you'd like. Nicholas, what are the little math blocks? Are we talking about like square inch tiles?
Yeah. I just have I've had a lot of these where you have all the little blocks and each represent like, there's little 3 or there's 10 like tens. And I know that that's something that we've done to kind of help students figure out well, different math things to combine them together.
Hmm. I guess I'm picturing like what is the concrete thing? Are they the kind that snap together?
Some of these ones do have them snapped together, like a magnetic ones, but they are just like just they're all color coded. So they'll have like they can put them together and combine them to get different outcomes. But I don't think the ones I've had are magnetic, but they're all like matching length. So you'll see a bunch that are like 6 or 5 or ones or tens or whatever they are. And you're able to use those to help you kind of visualize the math you're doing.
Okay. I feel like I've seen that before, but I've never used those, the kind that you're describing. So it's kind of like if I was imagining a bar graph, like this is the height of 1, this is the height of 2, and those are all different colors.
Yeah, exactly. So you'll have
Okay.
like the ones I had I think were little red ones and they were ones, but then like 5 was yellow and then like
Hmm.
blue was 10, things like that. They would
Yeah. So
have 10 little blocks in them.
mhm. Even just working with numbers is very abstract if you're not past that level already. And so this gives something concrete to it, which is really important. Um, it gives our students permission to think about the problem in a different way. Yes, that's the idea that to change people's view of math, we need to see problems in all different ways. And then we're going to start building up tools for different ways to solve them, like bar models. I'm just going to just click through that again, just maybe not this one, it was my messy one, but here we go. So I've got two bars because I've got an equation. This is the first part of the equation. This is the second part of the equation. I know they're equal because the equal sign tells me that. That means that they're going to be the same length here. I'm taking the 6x and I'm putting literally 6 of them. And I'm saying -3, which is kind of ugly because you can't really show the minus very well. So I'm saying that I'm going to take that -3 and add it to the other side and then make my x's equal. And now I see 21 plus 3 is 24. And then I've got 6 x's. And again, these next two sections could be animated in either direction, but next is coming up. That's my -3 and the 21. So the length of 21 and the 3 that was taken off of the other side is equal to 24. And then I can figure out what each individual x is. So assuming that x is positive, and it probably is if we're using this as a test talk, then we're going to take 6 steps the size of x. 1, 2, 3, 4, 5, 6, and then 3 steps back. That's where I've landed. There's my leap of 3, and I'm landing there. That is 21. So if I went 3 back the other direction where I landed with the 6x, I'm at 24. These are just some ways I collected to solve it. Some of these are in the blog, and then the egg one I added. I don't remember if the story table was in there or not, but these are every blog that's about one test question has a bunch of different strategies to solve it. And the directions for the test talk are part of a packet, and you're going to get all of these as links at the end. So the next components are wrapping up the steps that you would give them more time in the classroom than we're taking there. So I'm just going to go through these quickly. So step 7 is to ensure that students have a strategy that they like. Even though there's only one correct answer, there's no correct answer to which strategy is best. And this is a place you can emphasize that the important thing is that each person is able to make sense of the question and at least one strategy. They might not understand how, another student in class figured it out. Students can feel overwhelmed, like they need to learn all of them. So we have to be explicit about find something that resonates with you and make sense of that. Because it's not for everybody and it's not for every problem. It's just the idea of we're thinking flexibly and creatively. Step 8 is to encourage note-taking. Give time for them to pause and record the strategy that was their favorite and why they liked it. There's handouts that are in the packet. And it's so tempting to skip this because we always want to stop when we get the answer. But give time for students to be thoughtful about it so they can really internalize that strategy that made the most sense to them. Even if they don't keep their paper afterwards, that's part of the process for internalizing the strategy. And then finally, you'll facilitate a wrap-up discussion. This is where students can share which strategy was their favorite. It gives them a chance to solidify their learning, to lift each other up, build community. What is your favorite strategy? It might be their own, but it might be something they heard from someone else. So now that we've done a test talk and seen the behind the curtains teacher side, I want to be explicit about the purpose and make sure that we don't miss this. We want to help students apply and extend their learning in the context of standardized test questions, because that's what students come in wanting to do is pass the test and get their diploma. But it's our job to help support them in a way that will help them do their best, and that is in gaining this confidence with themselves as one way. It's to solidify learning and act as a formative assessment. I know what my students know if we've had this strategy sharing conversation. To empower students to think flexibly and creatively, and to build students' capacity to make sense of problems and persevere in solving them, which is math practice 1. And then we've got this last point. It's not to teach them how to approach specific test questions or question types. So like I said earlier, it's not like, here's how you do the systems of equations ones. Nope, we're not even going to tell them it's a systems of equation. And probably they could solve it with something else. So as long as you keep these important principles in mind, in that spirit of flexibility, feel free to adapt the test talk routine and use it as it makes sense for your class. I have a place where this routine is that I'm going to drop in the chat, but there's also lots of other routines that you can use for your class that involve strategy sharing. If using this talk seems kind of intimidating, and I would say that for me it would if I hadn't already done a lot of other talks. So besides lots and lots of instructional routines are these 4 specific ones. The 3 that come before it are good ways to start. So if I was doing talks for the first time with a group of students, even if I was experienced at giving talks, I would want to start with a dot talk because to me, those are accessible. They don't have numbers, and you're asking them their strategies, and you are representing it with equations, and it will help them see that this class is going to be about the strategies and how we all thought about it. And how interesting is that, rather than the answer to how many dots are on the screen, which is really actually boring. So it's about strategy and sharing and thinking, and it sort of sets that tone. There are 2 other kinds, fractions and number talks, that are also useful. So you could do some of those too, or you could skip right from doing a couple of dot talks straight to test talks. That's completely up to you. Again, flexible and creative. Here's our session's resources slide, but I'm also going to drop that in the chat. Here it is. So the packet has many of these with the strategies and the handout that goes with it, but you can do the exact same thing with the blogs. And that blog will just get you a search of all of the different ones. We're past like 55 at this point, I think, of posted blogs. The one that we did today together was number 50. Not number 50, it was the December one. And so I'm going to just post this up. The link isn't working. Which one of the links, Denise? Might have cut something off when I copied. No, that looks like that.
I just tested them. Both of them work for me.
Okay. How about the one, because the talks were also in the adult numeracy one, that link is working for y'all too? Well, I gonna click up another slide here and invite your questions, and I can put my contact information in the chat because yes, I'm here from Turk, but I also work for ATDN and offer coaching at advance.org. So if you would like to meet about how to do talks in your class or about anything mathy, GD, preppy, I would be happy to talk to you about plans or resources or any of that curriculum, anything you want to learn how to do in class, or a headache you're having with your students that you'd like to see if I have any ideas for. What questions do you have for me now?
It's tough. It's Friday.
Yep. And it is 2.
It is. Yep. Everybody's starting to wind down for the weekend.
Yeah. All right.
I'm going to go ahead and stop the recording. I'm just going to first thank you though, Connie. If you have questions, certainly feel free to throw them into the chat or unmute. But thank you for taking the time to join us today, Connie. And as she said, she is available to Connecticut in terms of support through E2DN for mathematics. So any questions you have, obviously, as we said, the recording and the presentation and all the materials will go out to you. But if there's anything additional or even things that weren't covered today specific to GED in terms of math, Connie is available and she is highly regarded. Stephen actually did a nice little plug for you, Connie, in terms of something with your graphs, slow revealing
graphs.
Yep. So he was talking about that. So we always love having you with us. But thank you for joining us today. And we do have one more session coming up. It is with Stephen once again. Let me get to the right screen so I can give you the exact title. And that is Close Reading, the Key to Success Across Content Areas. And that will begin at 2:15. So thank you, and hopefully we'll see you there.